Hi guys, in today's lecture and lab we will see how to use the analog interface for the Arduino. Now before I explain the analog interface, let us understand the basic difference between digital and analog signals. So digital signals have fixed levels 0 and 1, which could be 0 volts, minus 5 volts, some value, and logic 1 or level 1, which could be 5 volts, 3.3 volts, etc. So in digital you just have two levels or two logics, so logic 0 and logic 1. Similarly, in analog you can have any set of levels between two extremes. So between two extreme values, for example between 0 volts and 5 volts, an analog signal can take any value. So for an analog signal to be understood by the Arduino, so if you have an analog signal, you need to convert the analog signal into a digital signal which contains zeros and ones. So you need this converter, which is called an ADC. ADC stands for analog to digital converter. Now on the Arduino board you have the microcontroller, which has, so this is the microcontroller. The microcontroller has an ADC inside it. So the ADC, which was on the previous page, which I said you need the ADC, is inside the microcontroller on the Arduino board. So if you see the board here, this is your Arduino board, this is the microcontroller, the ADC is inside the chip right here. So if you have an analog signal, so on the board, this is the analog section here on the board, so you give the analog signal here. So on the graph, let's see this here, you give the analog signal and that goes to the ADC, and then it gets converted to zeros and ones, which can then be used. I hope that is clear. So how do we use the analog function? The function is called as analog read. So we use the function analog read, and this is the pin number. So you can use any of the pins A0, A1, A2, A3, A4 or A5, and the output of the analog read function is 0 to 1023. So the value is anywhere between 0 to 1023. Let me give you an example. If the input range is 0 to 5 volts, then for 2.5 volts input, the analog read function will give you an answer which is equal to 1023 divided by 2, which is, anybody? 512 approximately. So if it's 2.5 volts, which is in the middle of 0 to 5 volts, the answer of analog read is 512. So the output of analog read function is 0 to 1023. So now this, once it's clear, in today's lab we will take a potentiometer and connect it to the Arduino. This is the analog section, this is the power. So as you see here, this is your potentiometer on the board. We take the one extreme terminal of your potentiometer here and we connect it to 5 volts. We take the other extreme and we connect it to ground. So here, if you see, this is connected to 5 volts here. This terminal, which is the red one, is connected to ground. You can interchange these terminals, it's all one and the same. And we will connect the variable terminal of the potentiometer to analog channel 1, which is this one, the analog channel 1. So this will go to analog channel 1 right here. So this is 0, 1, 2. We will connect it to 1, as you see on the board right here, which is this one. So using the potentiometer, this terminal will give you an analog voltage which is from ground, which is here, 0 volts to 5 volts. So the range will go from 0 to 5 volts, and my pin number 1, I will use the analog read function to read the digital value. So let us look at the lab. What we will do is we will make the LED go on, we will make the LED go off, and in between we will have a delay. Which is equal to the digital equivalent of the analog voltage. So depending on what my potentiometer voltage is, so VDD, ground, so depending on what my potentiometer voltage is, I will do the analog read function and then I will vary this delay. So that is the basic lab where we will see the analog interface on the Arduino. So let us take a look at the code. So first I will specify the pin number. I call the pin sensor pin and I give it the variable A1. Since we connected the internal terminal A1 on the board, as you can see here, so we've connected it to A1. Then I will use the LED on board. So this LED here, this is the onboard LED. This is connected to pin number 13 by default, so we will use the pin number 13. And then I'm using the variable sensor value. So this variable will hold the value of the pin. So what we will do is, when I say sensor value is analog read, this is A1. So if this value is equal to 55, then this value will be passed on to this variable. So that is this variable here, and then what we will do is we will configure LED pin of the type output. After that, let's understand the program. I first perform the analog read function, so I get the value from here to here. Then I turn the LED on, and now depending on this analog value, I give the same amount of delay. So for that much time the LED stays on, and after that I switch the LED off, and again I wait for that much time before I read the value again. Okay, so this keeps going on and on. So it's a simple thing. I read the analog value from my potentiometer, and then I give the delay. So higher the analog value, higher is the delay. So now let's look at this output on the lab. So we will go ahead and program. Again, I would like to remind you, please take a look at your board, make sure that the board is correctly selected, and your serial port. And after that, let's go ahead and upload. Now you see the board is getting programmed. Please wait for the output. This is the board getting programmed. So now the board LED is on and off. As I change my potentiometer, you see that the delay is reducing, so the delay is going down because the value is going down. Now if I increase the delay, or I increase the analog value of the potentiometer, you see that the delay is increasing, and at maximum you find maximum delay. So let's go ahead and reduce it again. As you see, so what we are doing here is the potentiometer is giving us an analog value through this terminal on A1, and depending on that we are reading the value and changing the delay of this. So as a result of this lab, now you know how to read analog values. In the next lab we will see how to interface the potentiometer with the LCD screen which you've seen. So please revise this lab. You can try and change this connection to A2 and see what's the effect in the code, what do you have to do. I hope this lab is clear. I'll see you in the next lab. Thank you.